I'm Helen Walk. I'm a graduate student in computer science, and my project is working with several different professors. Professor Wai-Tat Fu, Chad Lane, Maya Israel, and Francis Wang. They're all from lots of different departments, and I'll be talking about an educational gaming platform for teaching spatial skills.
You hit the space bar.
Oh. Okay, so the basic idea is that spatial reasoning skills are really important for success in STEM fields. They apply to a wide range of disciplines, not even limited to just STEM. We've got architecture, engineering, math, chemistry. They all benefit from it, and spatial reasoning skills are shown to be a strong predictor of future success in STEM careers. You can look and see that dropout rate from STEM courses is correlated with spatial reasoning skills. So what can we do to improve spatial reasoning skills and increase STEM participation? So in the past, there's been a lot of research done on using games to teach spatial reasoning skills. And I just put 3 examples up here, 3 very different games: Medal of Honor, Tetris, Zaxxon. And what they do is they just have students play the games, and then they measure them on various spatial skills. So they know, oh, maybe this game increases this certain spatial skill, but we don't know why. So this research is trying to get out why. So we're looking at 3 different types of spatial reasoning. We're trying to break down the game into constituent parts. And these 3 different types of spatial reasoning are, on the left we have spatial perception, how you perceive yourself relative to other objects. And then in the middle is projection, basically transforming objects between 2D and 3D representations. And on the right is the idea of mental rotation. How would an object look if you rotated it a certain amount? So the game that we're proposing to do this with, basically the premise is you're on a spacecraft. You crash land on an alien planet, and there's all these strange ruins, and you have to find parts to rebuild your spaceship. So you have to build a bunch of equipment that'll help you explore the area. You can see the Lego picture there kind of conveys this idea of constructing useful objects from their constituent parts. So we have 3 game modes that roughly correspond to the 3 different spatial reasoning tasks we're trying to do. We've got exploration mode, which is just traversing the virtual environment in a first-person perspective, looking for useful parts that you can use to build something. That's sort of the spatial perception aspect. Then we've got blueprint translation, which involves acquiring a 2D blueprint of whatever object you're trying to build and matching it with representations of the 3D parts. And then we've also got the final mode, construction. Here you can see a very crude prototype of it that we've got. Basically the idea is once you have all the parts for a certain object, you enter this mode, and in virtual 3D you can manipulate the parts and put them into the correct places. So just to show a quick demo of some of this functionality, basically from this lower menu you can select parts and put them on the screen, and then you can rotate them to the correct orientation and then match them where they're supposed to go on the object. So you can select the object and move it around and put it in the correct area, select a new object and put it in the correct area until you've got your completed model. So things that we'd really like to do with this, the leap motion controller would be really useful for this because it allows a natural mapping between the actions that you're performing in the game and what your hands are actually doing, like to rotate an object or move it. This allows you to have very hands-based motion rather than just pressing buttons. And then we'd also like to do some 3D printing integration that would allow students to actually print out the models that they've built and the constituent parts. And looking forward, we're hoping to do some pilot studies on the game prototype sometime in April. And we'd really like to make use of the Illinois Simulator Lab in Beckman to help us with that. And we're hoping that this has the potential to apply to different educational games that maybe aren't focused on spatial skills but other content areas. And ultimately, we'd like to use this to enable people to use technology more effectively in education.